Hello, how are you? Welcome to a new video from the AbadIA and its most agentic version. Today we are going to talk about how to design agents that will help us a lot in this project. But I won't keep you any longer. Let's get started. Having all the tools isn't enough. We need to carefully design the agents themselves to create smart, believable, and effective AI for AbadIA. This video focuses on taking what we've learned and applying it specifically to game AI design. Potential roles of AI agents within AbadIA to tackle the complexity of AbadIA, a multi-agent system could have specialized roles. Game state agent, MCP Client, this one's in charge of seeing the current game state, e.g. character spot, time of day, inventory, NPC locations, clues found, by asking the game API through an MCP server. Narrative understanding agent. LLM-powered this agent slurps up all the text from the game, dialogues, object descriptions, journal entries, using Gemini/Gemma to figure out the plot, why characters do what they do, and to spot clues. Planning and reasoning agent, LLM-powered orchestrator. This is the central brain of the system. It gets info from the game state and narrative understanding agents, thinks through the mystery, forms hypotheses, and designs multi-step plans to investigate, interrogate, and solve puzzles. It hands off subtasks to other agents via A2A. Action execution agent. MCP Client, this agent translates high-level plans from the planning agent into specific game API calls, e.g., move to library, talk to monk, examine book, via the MCP server. NPC interaction agent. LLM-powered manages chats with non-player characters, using Gemini/Gemma to generate questions and answers that make sense in context, trying to dig out info or influence their behavior. Time/rule management agent keeps an eye on the in-game clock and makes sure we're following monastic rules, e.g., attending prayers, being in cell at night, reminding the planning agent, or even taking action on its own. Inventory/object agent tracks all the items we've collected, what they do, and how they might be used in puzzles. Applying LLMs for dynamic game logic and character behavior, making the game come alive. LLMs are super powerful tools that can do way more than just spit out text. They can really shake up the game experience. Dynamic narrative. LLMs can create branching storylines, change dialogue based on your choices, and even invent unique plot twists. In AbadIA, the NPC interaction agent could dynamically generate conversations with monks based on current clues and the time of day. Intelligent NPCs. LLMs can give NPCs distinct personalities and behaviors. This could make the monks in AbadIA react more realistically to William and Adzo, or even develop their own daily routines and secret lives. Procedural content generation. Conceptual. Even though AbadIA has a fixed map, LLMs could conceptually generate new clues, minor characters, or even small side quests within the existing game, making each playthrough unique for the AI. Problem solving and spatial reasoning. LLMs can be used for pathfinding or puzzle solving, even if they need tools, like a game map API via MCP, to overcome their natural weaknesses in understanding space. Codified profiles. Instead of just relying on vague prompts, defining character behavior with clear control logic, codified profiles can ensure consistency and let us easily check and tweak things, especially for smaller LLMs. The AI for AbadIA needs a well-defined cognitive architecture. This means the design has to spell out how the AI sees the game perception layer, processes info and plans decision-making layer, using LLMs and chain of thought, and does things action layer. This structured approach is crucial for building a solid AI that can actually solve the game. While LLMs are awesome for generating text and dynamic stories, game environments have fixed rules, maps, and specific interaction points. Agents have to be grounded in the game's reality. This means the AI needs to understand and stick to the game's rules, map, and available actions, avoiding hallucinations or doing things that aren't possible in the game engine. Using codified profiles to define character behavior can ensure consistency and let us systematically check and revise things, especially for smaller LLMs. This highlights the need for careful prompt engineering and tool integration to guide LLM behavior within the game's limits.